A positive charge of 1.5 times 10 raised to the power of negative 4 coulomb is placed 0.2 meter away from a negative charge of negative 2.5 times 10 raised to the power of negative 4 coulomb. What is the magnitude and direction of the electrostatic force between the charges? Okay, we are looking for the magnitude and direction. Now, listen to me. Let's start by writing out the information that we are given in the question. A positive charge of 1.5 times 10 raised to the power of negative 4. So the first charge, solution. So the first charge, Q1, is what? 1.5 times 10 raised to the power of negative 4 coulomb is placed 0.2 meter. So that means that the distance between the first charge and the second charge is what? 0.2 meter. So R here is 0.2. Now listen to me carefully. There are some instances that you are going to be given the distance between this charge in another unit, maybe in centimeter. You have to convert to meter. Do you understand? So make sure you pay attention to that. If this 0.2 is given in centimeter, I will have to convert in meter. I will have to convert it to meter. Do you understand? So because it is in meter, so there is no need for conversion. I just emphasize on that because there are some questions you might come across. Don't use the value directly if it is not in meter. Do you understand? Okay, so the second charge, which is Q2 is negative, so it is negative 2.5. Negative 2.5 times 10 raised to the power of negative 4 coulomb. Okay, now we are looking for the magnitude. Now, we are looking for the magnitude and the direction, but let us first determine the magnitude. Do you understand? Okay, please pay attention. I told you that remembering this formula is important if you want to solve any question on electrostatic. Are you getting it? So now, to get the magnitude of the force, electrostatic force between this charge, just bring out this formula F. Okay, let me change the marker here. F equals to 9.0 times 10 raised to the power of 9 times Q1. Q1 is 1.5 times 10 raised to the power of negative 4. Q2 is negative 2.5, you know, negative 2.5 times 10 raised to the power of negative 4 all over R squared. R is 0.2, so we are going to have 0.2 squared. Do you understand? Okay, so F equals to, now like we did in the previous example, we are going to take the product of this, and this. Do you understand? 9.0 times 1.5 times negative 2.5. That is negative 337.5. So I'm going to have negative 337.5. Now you are still going to take the product of 10 raised to the power of 9, 10 raised to the power of negative 4, and 10 raised to the power of negative 4. That is 10 raised to the power of 9 times 10 raised to the power of negative 4 times 10 raised to the power of negative 4. That is 10 raised to the power of 9 times 10 raised to the power of negative 8. So according to the law of indices, you subtract. So I'm going to have 10 raised to the power 1. So I'm going to have this multiplied by 10. Because 10 raised to the power of 1 is also the same thing as 10. Okay? Now 0.2 squared is what? 0.04. You understand? Okay, so force equals to, this times this is negative 337 all over 0.04. Okay, so divide this by, this will give us negative 837.5 Newton. Okay, now listen to me carefully. You see, you can see that the force is negative. You understand? We have a negative sign, but we are going to take the magnitude. You understand? So the magnitude of the force is 8,337.5 Newton. Listen to me carefully. If you have, or you take the absolute value, are you getting what I'm trying to say? If you have a negative, if you have your force or your answer as negative value, you take the magnitude. You understand? Or the absolute value. So the absolute value of this is, you are going to have the positive. Do you understand? absolute value of A, if you have negative A, the absolute value of negative A is what? A. Do you understand? Absolute value of a negative number will give you a positive number. Do you understand? So that means that if you take the absolute value of this, you're going to have this. Do you understand? Okay, so this is the magnitude of the electrostatic force between this point charge. Do you understand? Okay, now the force between this charge is attractive. You understand? And the reason why it is attractive is because the charges are not, they didn't have the same sign. You understand? In the previous example, the charges have the same sign, so that sign of force is repulsive. And this force, the direction of the force is towards the positively charged the direction of the force is towards the positively charged. If the distance between two charges is doubled, what happens to the electrostatic force between them? Okay, now if the distance is doubled, now distance is represented as r. You understand? So r equals to 2 multiplied by r. Is that not it? So I'm going to have 2r. That means that r is now 2r. You understand? Okay. Now, if the distance is double, don't forget that the electrostatic force varies inversely as the square of the distance. So I'm going to have 1 over r squared. Okay. Now, because r is now what? R is doubled. So I'm going to have 2r.
To watch the complete class, kindly click on the link in the description of this video or the comment section. Okay. See you in the next class.